Thanks for stopping by our YouTube channel. This is Christian Posta from solo.io, and actually on our YouTube channel you can check out a lot of the tech videos and so on that we've created, helping people navigate the landscape of service mesh and some of the exciting things that are happening in that ecosystem. One of those is the announcement by the Azure folks, Microsoft Azure folks, of Open Service Mesh, which is a new service mesh that's built on the Envoy proxy that implements the SMI, or the Service Mesh Interface. Now, here at Solo, we've been talking about SMI and these service mesh abstractions and APIs for a while. It's good to see that these concepts have taken hold across the market. Now, what we want to do and show in this video is how to, if you go to the OSM GitHub and their documentation, there's a particular section that is interesting to us here, and that is Ingress, getting traffic into the cluster, into the service mesh. Now at Solo, we've been working on a broad set of technologies to operationalize service mesh. One of those is the edge. One of those is the API gateway, or the Ingress. And out of the box, you have options for Nginx, Azure, and Gloo. Gloo is our API gateway, also built on Envoy, to allow traffic to come in where you need a little bit more power at the edge. You need things like OIDC, or web application firewalling, or open policy agent enforcement, or rate limiting, these types of things. And Gloo implements that really well. So in this demo, we're going to take a look at our OSM has been installed on this particular Kubernetes cluster. We are going to see that Gloo has already been installed on this Kubernetes cluster in Ingress mode. So it's important to point out that for this demo, we're going to show it in Ingress mode right here. But Gloo's more powerful capabilities are available in gateway mode. You can go check out the docs to see that. In our default namespace, we have 3 applications deployed. We have web, and we have backend. So web calls backend, and then sleep is just a little helper service to allow us to call and validate what the traffic looks like. So if we look at our demo here, and we see those pods, we should see when we call from the sleep pod, when we call web, we see it returns a backend. Now this is using the fake service from Nick Jackson. Thank you, Nick. And what ends up happening is when we call web, it automatically calls the backend as well. And you can see the responses from these different services. Now, what we want to do is enable access to this web application from outside of our mesh and outside of our cluster. So what we're going to do is we're going to create this Ingress resource and route traffic to our web Kubernetes service here. So if we create that, what this is going to do is, if we come back here to the docs on Ingress, what we'll see is by default that HTTP traffic is now enabled for our service, so that if we call it from, well, if we look at the Ingress, if we call it from the Ingress perspective, it should go through. Now, OSM uses mutual TLS between its services. And when we created this Ingress, what it did was open up a HTTP route so that we can also call the web service using the Ingress approach here over HTTP. But what we want to do is secure that traffic and encrypt it. So what we want to do here is, if we come over here and look at the docs for OSM, what we need to do is set this particular variable to true in the OSM config map. And that will enable HTTPS traffic for Ingress. So if we update that, let's actually go take a look to make sure. And we see that we've now patched that particular config map. So now when this happens, traffic coming in to the ingress will be coming in as HTTP. We can secure that differently using Gloo or whatever other ingress controller. But then that hop from Gloo to the OSM managed service, in this case web, that will happen over HTTPS. Now, the truth is, we've not configured Gloo to be part of this HTTPS yet. So if we call it, we should see a failure here. And we do. And if we looked in the logs, we would see that this connection failure is happening because the Gloo tries to call web. Web is managed by OSM, and OSM is presenting TLS certificates that Gloo doesn't understand, Gloo doesn't trust. So it's an invalid HTTPS connection. So what we want to do is actually get the CA that was used to sign the certificates that OSM is using, and we're going to import those into Gloo. And from there, so we did that. From there, we can update our in Gloo. Gloo routes to resource upstreams, and upstreams can be any value. It can be a Kubernetes discovered service, a Azure function. It could be a console discovered service, or any registry, right? So it's just a representation of a routing target. And in our Gloo upstream, what we need to do is configure the TLS properties so that when Gloo calls this particular service, it will be trusted and it will work. So if we update our upstream in Gloo, and everything in Gloo is based around CRDs, when run in Kubernetes, I might add, but it doesn't have to run in Kubernetes. And right, so let's get our upstream. We should see that we have the new configurations. And now if I make the call, it shouldn't fail, it should work. And it does. Now the traffic is coming into Gloo. Gloo is connecting to the web service, which is in the OSM service mesh. And that link is being secured with one-way TLS. So I encourage you to take a look at OSM. And of course, if you're going to use it, you need to expose it to other services outside of the mesh, perhaps. And Gloo is a very powerful open source API gateway built on Envoy proxy, which provides some of those powerful features. So again, this is Christian Post. So take a look at our YouTube channel, and we look forward to the next video.